Hello guys, and welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today, we're still in the realm of statics. We're still in the same problem as the problem we tackled in the previous video, because we want to solve it with a different method, right? So the last time we went over this together, we decompose the forces, and we used the force decomposition to be able to solve the problem and arrive at the two answers that were prompted, right? Now, we are going to solve the same problem, but then with a different method using the force triangle. And obviously, like I said in the previous video, and if you haven't checked that video out, you can check it right here. But as said in the previous video, the idea here is use a method you feel we're the most comfortable with. Both are 100% correct. Okay, so how are we going to solve the same problem in a different way? So what we have here, let me go ahead and delete, or maybe just copy some of this. Sorry, let me just copy this down here. Okay, so what we're going to do here is remove anything that we don't need. Don't need the force decomposition anymore. We're not doing it this way. This is all we have, okay? This is the information we have right here. Boom. Okay, and what we're going to do is we're going to copy on this over here, okay? And we are going to close this triangle with a vertical line. Now, very important, okay, very, very important. If we didn't know the resultant was vertical, we might be tempted to close this with a vertical line, when in reality, it's slightly tilted, okay? And when that's the case, that's where students are completely caught off guard. We actually did a problem, if you want to look at our video bank, there's a problem in which it's very similar to what I'm saying. It's one that 2.48, in which there's a guy helping to lift a heavy weight with the assistance of a crane. And it looks like it's vertical, but it's not. And if you do it vertical, you are going to go on the wrong path, okay? So just watch out for that. In this case here, however, we know it's vertical, so super easy, no stress whatsoever. First thing I need to do, okay, I have a triangle. Let me close off my triangle here. Boom, boom. Okay, I have a triangle. I have one of the angles of the triangle, and I also know this angle here with the 30 degrees, that this makes us a vertical line. If that's 30 with the vertical line, this is also 30 here with the vertical line, right? And while, this is very, very intuitive and easy to see for some of folks that are more used to triangles, I think it's always useful for us to remind ourselves why that's the case, okay? So let's go ahead. I'm going to go ahead and draw this situation that we have here really quickly so that we can prove quickly this is the case. Okay, so we know this is 30 right here, correct? 30. All right, what else do we know? We know that this is 90 right here, right? So it makes 90 degrees here, okay? We also know this is 90 right here. Okay, so what is this angle here, the purple one, if you will? Well, that'll be 90 minus the 30, right? So that's 60. So this right here is 60. Okay, what about this here on the top? Well, we know the whole thing is 90. We know this guy here is 90. And therefore, let me change colors. This orange one needs to be 180 minus 90, this 90 here, minus 60, this 60 here. Okay, and if that's the case, then this is 30. And if this is 30, this is 30, right? So back to here, 30, okay? So just proving that out real quick. So we have a triangle with 30 and 25, which means that this guy here needs to be 180, total of the triangle, minus the 25, minus the 30, which gives us 55, 125. Okay, so it gives us 125. Why is that important? Because now I have defined this triangle basically, come on, 125. Basically, I have completely defined this triangle. All the unknowns I can possibly wish for, I can grab now, because this black line here, this is my resultant force, right? Force resultant. This purple line here, or sure it's pink or purple, is my P, okay? And what do we know about the law of sines? We know that, let me just push this to the side so it doesn't get in our way. What do we know about the law of sines? We know that the sine of 30 over the corresponding side, which is my 120, so sine of 30 over 120 newtons equals the sine of, which, that's the next one, 25, and the corresponding side, which is P, or over P, which is equal to the sine of the one that's left over, the 125, divided by the FR. So note that I have three equations, or two equations, I should say, and two unknowns. Okay, and therefore very easy to solve it and very straightforward. So if I'm looking for P, well, part A, let me do this. Part A is asking what is P, and therefore P is equal to, I'm just going to grab this side of the equation. I'm going to solve for P, so P is going to go to that over here, and 120 over here, and 30 over here, right? So P is going to be the sine of 25 divided by the sine of 30 times 120 newtons, which is equal to, oh, actually, no, that's equal to, right? Because we did exactly the same math before, right here. Check it out. Sine of 25 over sine of 30 times 120 equals approximately 101.43. 101.43 newtons. Boom. So that's one of the answers we're after. What is the second part we're after? We're after what is the resultant force. And guess what? Easy peasy too, right? So part B, what is the resultant force? Well, I'm just going to grab, we can choose whether you want to do this one here because you already know P now, or if you want to do this one, which is the one you knew all along, and make it equal to this, you can too. Whatever rocks your boat, both are going to be right. So I'm going to go ahead and do the one I just highlighted, and my resultant force will be equal to 120 times the sine of 125. 25 divided by the sine of 30 degrees, which equals approximately 196.6 newtons. And this hopefully matches what we have up there. Let's check here, 196.6. Yes, we did right here. Okay, beautiful. Right, so in this specific problem, I think the force triangle is actually super straightforward, right? Build a triangle, get the angles right, you have all the equations laid out. Me personally, I always like to use force decomposition. I'm just used to it. I think it's, the logic behind it is, I can follow a solid logic behind it. It's easy for me to understand. So I generally tend to go with this, but obviously the results are exactly the same. And if you find this one to be more easier to understand or easier to apply, by all means, both are completely within your grasp, completely okay to use. So I hope this was useful. Let me know which method you prefer down in the comments. If you have any questions as well, please leave them down below. If this video was useful or helped you out somehow, consider leaving a like, and we'll talk to you.